In this video, we'll demonstrate how engineers can build predictive models for critical parameters and automate them for continuous monitoring. Our example focuses on oil temperature in a turbine, a key indicator of equipment health. The first step is getting the past operational data from the data source. In this case, the AvivaPi system. Define the desired time span, temporal resolution, and select relevant tags to import. Let's select the oil temperature from the variable list. Here we can observe the oil temperature over the imported time span across normal operation and shutdowns. Since we're interested in monitoring oil temperature during stable operating conditions, we filter for steady-state periods. Using a built-in function, we isolate periods where the oil temperature changed by less than 2 degrees Celsius over a 4-day window. Then, we filter the data to only keep these steady periods. Now, let's also have a look at the water temperature sensor, which is one of the important factors on oil temperature. Let's have a look at this relationship in a scatter plot as well. We see that the oil temperature versus water temperature relation mostly follows a certain corridor of plus or minus 0.5 degrees Celsius, a good indicator for modeling. Now, let's build a model for oil temperature using water temperature and potentially other relevant parameters. Visplore will automatically select the relevant inputs. We can see that a polynomial model using water temperature and additionally oil level in tank as inputs was fitted. Now, let's define an anomaly detection based on the expected oil temperature provided by the model. Any deviation that is bigger than 0.5 degrees Celsius and lasting at least 24 hours will be considered as an anomaly. Of course, we would like to get notified as soon as possible whenever such a deviation from the model happens in the future. So, let's create an automation task which will alert relevant people when this happens. Let's add images directly to the email, the time series plot, and the scatter plot. This way, we see already in the email if we have a real alarm or a false positive. We can specify who should be getting the alert email. And as the last step, we can schedule the detection for every 2 hours. And state that it's always applied to the most recent 14 days of data. And save the session to the server, so the server can handle the rest. The user receives an email alert, as set up before, whenever the oil temperature deviates from the model, and they can easily determine whether this is something they need to act on. In case of a need for a deeper analysis or further confirmation, it takes only one click to start Visplore and load the relevant session directly from the email. To summarize, we have built a prediction model from historical data and set up an alarm for deviations within minutes. The benefit is not just that, it's also that engineers can set up and maintain condition monitors themselves, fast and easy for many types of sensors and equipments, and without any programming. This can easily save hundreds of thousands of euros for production loss, and even more for prevented equipment damage. Trusted by customers worldwide for self-service analytics and automation. Talk to our experts and learn how self-service automation increases your awareness and prevents downtimes. Get in touch to learn more.